Hello, this is Aniruddha Ghosal. I am an adjunct faculty in the Department of Mathematics at Adamas University, and this is the first lecture series of my content, which is titled as Introduction to R Programming. So before we start with R programming, let us get a basic knowledge of what it is. Since it is a programming language, we're going to use codes and algorithms to solve different kinds of problems. Now, there are many alternative programming languages as well, such as C++, Java, Python, and so on. But even among them, R has a special space among the beginners and those students, especially who are starting coding for the first time. This is because R is an open source software and it is mainly run on packets. Packets are nothing but bundles of codes which are helpful for creating and solving different kinds of programs. Since it is an open source software, the users themselves have studied how the packets work and they have modified and even made new packages, which has only helped how the problems are solved in our programming. So R itself works with its visual counterpart, RStudio. So we use R and RStudio both to solve the different kinds of complex problems that we get, mainly in the fields of mathematics, statistics, and data science. But it is a normal coding language which can be used for the domains of any students who are interested in learning coding. So before we start with R programming, let us first know how to install R in our particular device. And also, R is completely compatible with all kinds of operating systems. So, and it also has a very less system requirement, so it can be done in almost all of your devices. So let me share my screen. So to install R, first we go to our browser, then we type r hyphen r hyphen project.org. This is the website where we're going to download R. Okay. So after that, we can directly go to this particular place, download R. From there, we can go to this zero cloud, this particular link. Now you can also go to India, let's say here, and use this particular links to download a. And based on the country that you are residing in, you can go to your specific country. Most of the countries are specified here, and there are multiple different links from where we can download our. But if you want to get the most compatible cloud version, you can go to this zero cloud. So let's say I'm clicking on this particular link. Then we are redirected to this page where we can download R for Linux, R for macOS, R for Windows. Now, based on your operating system, you simply have to click on which particular file you want to download. Since I'm using a MacBook, I will be using this particular link, download R for macOS. So when you click, this particular file comes, and this has all the APKs of the R based on your operating system. Now, it's obviously recommended that you go for the latest version. If you could have used it for the Windows, here also there were different kinds of versions here. Since I was using Mac, for Mac, if I wanted to download now, I would be downloading this particular version, R4.3.2 ARM64 package. If anyone is using Windows, they can go to this particular page and they can go to base. From base, they can download, see, R4.3.2 for Windows. This is the latest version of R. With time, this version will also get updated. So whenever you are going to download R for the first time, you are only going to get the latest version. Similarly, if you want to download R for Linux, you can go to this particular page and you can see all of the updates that has been given. See, this Debian is the latest update that was last modified on 23rd November 2023. So you can simply click on this link and the raw file for R will be downloaded on your computer. After that, you can simply follow the normal instructions and install it. So once you install R, you are going to get this particular version, R, in your device. You can simply launch it and the main R console looks something like this. Here we can write any kinds of commands to get our solutions, or the basic coding of R starts from this particular window. But we are not only limited here. We are now also going to get the visualization counterpart of R, which is called as Art Studio. So to download our studio, we now also have to go to this particular page. Let's say for Art Studio, we can either write rstudio.com. This is the official web page for downloading our studio. But remember, you can only download and use our studio after you have installed and run R. Simply our studio will not be working. Our studio is the main component where we are going to work, but without R, this is not going to work. So always remember to use and download R before. So once we have downloaded and installed R, we can go to this particular website, rstudio.org, and we can download R Studio. You can simply go here. After that, see, there will be two different versions. The one will be R download R Studio, one will be download R Studio server. Now the server one is you can skip downloading the application on your device, but you can still use internet connectivity to work on the R on a cloud or a network remote basis. However, we're supposedly going to get the application itself because many of the functionalities only work on the application. So if you simply click on download R Studio, see, they are asking you to first install R. Since we have already installed R, we can directly go to install R Studio here. As I previously mentioned that we had to install R. So instead of going to that website, you can also come here and go download and install R. But clicking on this link will only redirect you to that previous website. So once you are done with R, you can go to here, install R Studio, that is download R Studio desktop for macOS 12 plus. So see, once I've clicked, it has started downloading R Studio. Okay, so once this is done, I have to simply again follow the instructions and install it. That's basically normal. So after you have installed, you are going to get this one, R Studio in your device. So you can launch it. So on the launch pad, we're going to get this particular window. This is the home page for R Studio, where we can write different kinds of programs and utilize it to solve our complex problems. Now, as we can see, there are 4 different windows present in R. Right. Now see the first one on the top left-hand corner. These are called windows or panes. So the very first window is called the script or the source window. This one. Here we can write our programs. We can write whatever we want here, and using those, we can solve the programs. Let's say we're trying to do a very basic calculation, that is 2 plus 2. So after we have written this particular command, if we simply click on this particular button, run, we're going to get our output. Now, we are writing it on the script window, but whenever we're going to get the output, it is going to come down in our console window, which is here. Now see, in the console window, it is also showing whatever the input commands that we have given and the output that we are going to get. We can directly write the commands in the console window as well. Let's say I want to do one more calculation, a very basic calculation. 1 plus 4 plus 9. Right. But here we do not need to click on anything. We can simply use enter button to get the answer. See, we are getting 9 plus 10 plus 4, 14. Okay. Now, if we can write the input directly on the console window and get the output here, then what is the use of this particular script or source window? Because in the console window, we can't go back. Even if you try to go back to the previous commands, we can't edit the commands or the codes which you have already given. So if we go to the script window, we can write a new program. Let's say 1 plus 3 plus 8. Now here, if we use the run button, we're going to get the output here. But now see if we want to change this particular command. Let's say I mistakenly wrote 8 here, where the answer original output would have been different. So now if I want to change the command entirely, let's say I want to give 3 into 7 into 41 on the exact same command space. And now if I run the particular command, we're going to get the answer. Now let's say I mistakenly wrote 41 here as well. It would have been 43. So I can simply edit this particular part and then again run the particular program and we're going to get the answer. Another usage of the script window is, let's say if we want to run both of these two commands together. So what we do, we select them both and then go to the run button. See, now we're going to get all two of the outputs together. Also, if we have already written two commands and if I want to specifically run the first program itself, then what do? I only select the particular row that I want to execute, or I place the cursor behind the particular row. After that, if I run the command, see, we're only going to get the output of the row that we specified. So this is an advantage of using the script window over the console window, where we can edit the commands if we make any mistake, or also if we want to specifically run any particular command from a set of commands that we have already executed, or if we want to execute all of the commands together at once. We can do that in the script or the source window only. This is why we mainly use the script window to write the programs, but we see the output in the console window. Now we also have the environment window here. The environment window is nothing but the place where if we load a data set, it comes in this particular space. Now, what is a data set? A data set is a collection of values which either it is already inbuilt in R or RStudio, or we have to download it from the external places. Now, this data set is important because we are mainly going to work on the data set, right? Unless and until we're going to get data, we can't really execute any kind of study or reference or interference on them. So we're going to get the data. We can load a data from here. Simply write data, and we're going to get a blank bracket. Now, if I execute this, what were we getting? We're getting different kinds of data sets that are already inbuilt in RStudio. Now, see, we were initially working on our script window in this particular panel, which is untitled one. Why it is untitled? Because I have not yet saved. If I save this name with any particular name, this untitled one would have been changed to the name that I give to this particular file. Now, once I've executed this one, data, we are going to get R data sets or all the data sets that were inbuilt and present in R. Now, among these various data sets, let us choose this particular data set, iris. Okay, now what does iris show? Iris was first given as Ager Anderson's iris data. So if I want to see what the data iris is all about, what do I write? I simply write data, and now instead of blank, I am giving the particular data set that I want to see. So now if I execute this particular command only, see, in the script window, it is showing data iris, that is the dataset of iris. And in the global environment, we're going to get the dataset loaded. This means that now we can work on the iris dataset. Now it's showing a summary of 150 different observations of 5 different variables. So we can simply click on this particular panel and we're going to get what are the data present in the iris dataset. Now instead of doing this manually, we could have also used a different command which is called view. If I simply use the command view and write it is this data set, and if I run this particular command, then also we are going to get the same output. That is, we're seeing all the different values present in the R dataset. Now, what did the summary show? The summary showed that iris contains 150 different observations. So see, there are 150 rows having different observations and 5 different variables. Which are the variables present here? It is a sepal width, and species. So 5 different variables of 150 different observations are present in this particular dataset, which is called iris. So this is how we can use any dataset. Now, even when we are trying to view or work on a dataset, we are writing it on the script or the source window, and we are getting the corresponding output on the console window. And whenever we are loading a dataset or any package, we're going to get its update on the global environment. Now we also have another particular window here, which can be used for plotting. Plotting means we're going to get the visual representations of whatever commands we are providing. Then there are packets. Packets, as I already mentioned before, these are nothing but bundles of dataset or commands, which will only make the working in R or RStudio easier. Then there is a help desk particularly here. If we particularly forget about any kind of command or how we can execute a different kind of program, we can take the reference from here. And there are also many different tabs present here, but we're mainly going to use it for plots, packages, and help. Now to clear the console window, since this one can't be edited, if you want to clear the console window, we mainly use a keyboard shortcut as Control L. Once we type Control L together, the console window becomes clear. And since the script window can be easily edited, we can simply delete all of the values. Also, if we want to reset the environment here, which is already loaded with Iris, we simply click on this broom icon. This broom icon means dusting off or deleting. So if we press on this broom icon, it will give a confirmatory message if I'm saying yes, and my global environment is now empty. So this is the most basic idea of how RStudio looks like and how we can work on the RStudio. Now, there are many types of package and codes that we can use, but whenever we're starting with a program, we start with the most basic code of all in R, that is datasets. So to load the datasets initially, we use the command library, and inside the library, we write datasets. So this is where now all the basic packages of R have been loaded. So the basic package here, base, is now ticked. This means the most basic package of R has been now loaded in our studio, where we can now perform different kinds of functions using the base package. Now continuing with the iris dataset, if I want to load it again, what do I have to do? I can simply write data iris and see the dataset iris is now between two inverted commas, or it is treating it as a variable. So if we run this particular command, we're once again going to get in our environment the iris dataset. So instead of viewing the entire dataset, let's say we want to get a quick look on how iris looks like. So we can use two different kinds of commands. One is head of iris. This means that we want to see the first 6 lines or the first 6 observations of all the variables present in the particular dataset. So if I use head iris and execute this particular command only, see on our output, which we are obviously going to get in our console window, we are saying only the first 6 observations. If we want to see the entire dataset, we had used the command previously known as view, right? So in view iris, we got all the 150 outputs or all the 150 observations that were present in iris. So if you want to execute this one, see there were 150 rows, 150 rows, right? Which was also given in this particular summary. Now I wanted to get a quick overview or quick look of how the iris dataset looked like. So I could only see for the first 6 lines, let's say. That's where we're using the head iris command. Similarly, if I want to see the last 6 lines or the last 6 observations of the dataset, we use the command tail. Once we're executing this, see, we're seeing the last 6 rows or the from the 150th row to the 150th row of all the different variables. Let me clear the console. And if you want to see both the first 6 lines and the last 6 lines of any different dataset, then what I can do, I can simply select both of these commands and do a quick run. But see, we are getting two different outputs. One is showing the first 6 lines of the dataset, another one is showing the last 6 lines of the dataset. So this is how you can get a quick overview and look of any dataset we want. Then we press Ctrl Alt again to clear the console. And if we want to clear this one, we can simply select the lines and delete them. Now this was to get the first 6 lines or the last 6 lines. But what if we want to get a statistical summary of the dataset? There we use the command summary. Summary means we're going to get the basic congested or a condensed idea of how the dataset is distributed. So let's say I want to see the summary of the same dataset, iris. Then I run the program and see we're going to get the different values of the minimum, the first quadrant, the median, the mean, the third quadrant, and the maximum value. Now it is not only coming for one of the variables, but all the variables present here. There were 5 different variables. So it is showing the minimum, first quadrant, median, mean, third quadrant, and maximum value for all of the different quadrants. Now what we need to see here is, if we had checked the iris dataset thoroughly, sepal length, sepal width, petal length, and petal width had numerical values as their observations. And in species, we could see it was Setosa, versicolor, and virginica. That is, there were no numerical values or only non-numerical values were observed in the species variable in iris dataset. So when we are typing summary, since species does not contain any numeric dataset, what it is doing, it is only showing the total number of the different subtypes of the variables present in species. So it had setosa, which were present 50 times, or the frequency of setosa was 50. Similarly, versicolor was appearing 50 times in the dataset, and also 50 was the frequency of virginica. Since these were non-numeric data, there were no particular way in which R could have calculated the minimum or the median or the mean or any other kind of summary statistics. So that's why this particular species variable is coming as a only the frequencies of the different subtypes present in that particular variable. As for the rest, this all of them had numeric data. So for the numeric data, we are going to get these 6 different types of calculations. So this is the use for the summary command. Now we have seen the most of the uses of these two and panes. Similarly, if we want to load any particular data set, we can see we can get the particular data or command or package in the environment window. Now we want to see the visualization. So let's say I want to plot the iris dataset. So what do? We simply use the plot command. It's very easy. Plot means we are trying to plot whatever data is present in the iris dataset. So let's say I'm giving plot iris. And when we want to execute this, see what we're saying is plot iris. And the plot is a visual output, so it will obviously not be present in console. So it is coming in our plot window or plot pane. Now see, this is a scatter plot matrix where the variables are present in the diagonal and the different scatter plots, one with respect to one with each other, are present in the rows and columns. Now this seems very congested, so what we can do is zoom the window. So now see, the scatter plot becomes a little more clear, where the diagonals are once again filled with all of the variables present, and the different scatter plots with respect to each other are given among the different rows and columns. So this is how we can plot any particular data set in R, and the subsequent plot will be showing up as an output in the plot pane or plot command. Once again, we can simply clear the plots using this particular broom, which once again signifies that we want to delete the content present in that particular pane. So once we click on the broom, it will show a confirmatory message again. So if we say yes, the plot pane is now reset or deleted. So this is one of the most basic ways in which we can visualize the data present in R. Similarly, there were many different data sets present in R. So to see all of the data sets, we keep the space between the brackets blank. And if we execute that, we're going to get all of these data sets which were already inbuilt and present in R. Now, these were not present in R from the beginning of time. They were only developed and implemented by users over time. So even we can make our own data set, and we can also aspire to increase the datasets present in R, which can only make the usage of future users easier. So let's say I'm choosing one more dataset. Let's say I'm choosing this one, CO2. So what do we write? Data CO2. Okay. Once I execute this, see, now we're going to get a different pane here in the global environment. Our iris data is also present because we have loaded it, right? And we had worked on it and we have not yet deleted it. So the iris data set is still present in the global environment. But now we have loaded one more data set, which is called CO2. And see, the summary is given as a time series from 1 to 468 from 1959 to 1998. Now, in the same pane where we used to get the plot output, there was also command for help, right? So if you want to use the help command, we can simply use a question mark and write down on which particular word or topic or package we need help for. So let's say I'm giving help for CO2, which is nothing but the dataset that I just loaded. If I execute this command, see, on the help pane or on the same pane where we used to get the plot output, we're now getting a different output, but now it is showing what is this dataset all about. This was a basic summary that it contained time series data from 1959 to 1998. But see here, we can get a detailed information about what this dataset is all about, who documented it, who first implemented it, and how we can use it for helping in our calculations. So once again, if I want to go back to this particular page, plots. Now, if you want to see those particular data set, we once again use the command view CO2 or the dataset that we wanted to see. So So this is the dataset that is coming. If you want to see it, probably the dataset was documented in this particular format. So if we use the view command, yes, we're going to get the data present in this particular dataset. And once again, we can use the head CO2 or the tail CO2 as well. See, one more advantage of using this particular pane is even when we're giving an enter here, we're only going to the next line, but the program is not getting executed by itself. So unless and until we select that particular line or command and use the run button, we're not going to get a program execution. So even on tail, if let's say I want to write CO2, and now if I want to run both of these commands together, so I select both of them and do a run. Now see, the first one is showing the first 6 lines of the dataset, and the last one is showing the last 6 lines of the dataset, as we already previously see. Then if we want to get a quick summary, we simply write summary again and use CO2. And see, summary of CO2 is showing different types of data present here. Now see, there were 1, 2, 3, 4, 5, 5 different variables present. Among them, see, the first one had only non-numeric value. So it is showing the numbers again. It's the same for the type and treatment variable. However, for this concentrated and uptake variables, there were numeric data present here. So we are going to get again the minimum first quadrant, median, mean, third quadrant, max. All of these values are now calculated for the concentrated and uptake variable, but not for these three, because these three had non-numeric data. So this is a basic idea how we can get different types of data sets, get a basic idea about them, want to see them, want to get a quick summary of them. And let's say once again, we want to plot this particular data set. So once we run this command, see, once again, we're going to get a scatter plot. Let me zoom it for a bit. So on the scatter plot, we're going to get the variables on the diagonal, and the respective scatter plots with one variable with each other are now present in the different rows and columns here. So this is how we can plot a data set, view a data set, see the first 6 lines or the last 6 lines of a data set, and get a quick summary of the data set. So this was the very first introduction about how we installed our R Studio and what is the main functionality and what is the basic usage of R, where we can use datasets to see various types of outputs. So once again, we can clear the package here. We can clear the global environment here. If we want to clear the main window, we can simply select it and delete it. If we want to clear the console window, we can just click Ctrl and L. So that gave us a basic idea about what R and R Studio is. I'll be continuing this lecture series on the next lecture, and we'll be learning about the next bit of commands and series where we can deep a little bit further in how data sets are represented and how different types of data calculations are present. So that's really all for today. I'll be seeing you in the next class. Thank you.